Good morning, and thank you for attending. My name is Gia Hodges, and I will be the moderator for today's webinar, 4 Ways to Maximize Your IoT Visualization Adoption. Today's speakers will be Tom Lubinsky and Praful Bayani. Tom is the CEO of SL Corporation, and Praful is our Vice President of Business Development and Strategic Projects. Today's webinar is intended to present a few concepts we have around IoT visualization and how to increase its adoption within your organization and with end users. And what kinds of techniques can you use to accomplish it? The agenda for today's webinar is that we will provide a very brief intro to SL and the kinds of problems we help our customers solve. We will also discuss the importance of data visualization, a case study, and then we will review the 4 ways. Now I would like to introduce Tom.
So we have been in the business of basically visualizing complex mission-critical systems since 1983. We've been involved in many different types of process control, network management, electric utility, application monitoring, many different types of visualization. And so as a result, we have developed a fair understanding about the things you need to do to make visualization work for your organization. I'm going to hand the reins over here to Praful, and he's going to talk about some of the reasons why. Praful has been with SL for a couple decades here, and he's got quite a bit of experience in process control and sophisticated monitoring systems. I'll give you a bit of background.
Thank you, Tom and Gia. Welcome, everybody. Thanks for your time today. So as Tom mentioned, we've been in this business of real-time data visualization for many, many years now. And the picture which you see here is the International Space Station, which is sending some real-time information and actually data back to Earth. And we are monitoring that in our product RTView. It's sending information about its position, about the pressure, temperature, and such. SL has 2 distinct markets. First, on the left, what you see is a real-time data visualization for industrial applications. And these could be, the industrial control systems, factory floor systems, network management systems, the space launch control systems, and also, of course, IoT. And on the right, what you see is the infrastructure monitoring. And this could be the infrastructure where your IoT or non-IoT applications might be running, typically on systems like the messaging systems or the application integration software or application servers, web servers, virtual or physical hardware. All this, are part of the bigger umbrella which we call as middleware, and we do middleware monitoring very, very effectively for many, many years now. So today's topic is how to increase the user adoption for visualization. And there are 4 important things I would like to talk about. One is, you collect all this data from all these different systems I was telling you about, and now you're ready to distribute that information and empower your users so that they can build some ad hoc and custom visualization. Not everybody would like to see the data as the tool provides in a certain way, but you want to create your own custom ad hoc data visualization also, and you should have the flexibility of that. Number 2 is there's so much of data out there today. I was reading somewhere that it's increasing like every other year by 3-fold or 4-fold or something like that. So there's a lot of data out there. So unless you provide some context to that data and make some good information out of it, that data is just a data point. So the ability to provide some context is very, very important. And then, of course, your data got to be dynamic and real-time. Not every use case needs real-time data, but if you are in the business of making some real-time decisions, you better have some good real-time data. And then, as I said, there's so much of data out there, and it's increasing, and all these different IoT applications are also expanding in a very, very fast way. So your visualization systems architecture should be scalable and it's going to be high performance. You got to be able to do, it in a very, very efficient way. Okay. So the real-time data visualization, as I said, could be, the industrial control systems, remote monitoring, telecom systems, aerospace, defense applications, and such. And on the right, what you're seeing is a partial list of some of our customers who have embedded our technology in many of their products, and they've been reselling our product for many, many years now. So based on our experience in the process control, industrial application space, and also recently for the past few years in the IoT space, we think there are some similarities between these two technologies and spaces. And we're going to talk about that in a few minutes. Visualization is not only, just creating dashboards. It's a lot more than that. Some people think you could get some free widgets from the internet and attach it to some data, and there's your dashboard ready. No, that's not. I mean, it's good for if you're a single person shop, but if you want to build a robust industrial system, then you got to take care of these five things. Number one, got to be able to collect data in real time. Go to the source directly and collect the data in real time. You don't want to, pick up the data from your database. That's not a good practice. The second thing is the data integration and transport. You're collecting data from all these different systems, and now you have so much of data. You got to be careful about how you want to transport your data. You don't want to transport everything from your sources to your applications. Got to be careful. You got to have good filters in there in order to transport that data effectively. The third important thing is your data storage. You want to store your data in your cache as well as in a database for historical analysis. You want to store the data in the cache because if you may not be monitoring the systems all the time. So if you want to see something and go back in time and look at something, how the data has behaved, it's good to have the data stored in the cache for a few hours so that you can go back in time quickly, more efficiently as possible. And then if you want to do the data, store the data in a database for historical analysis, you would push it out to a database. And you got to be able to store the data either at the edge or the application level, or maybe in some of the cases even at the device level. Now, having gotten all this data, and there's so much of data, you got to be able to normalize the data, aggregate the data, and be able to correlate the data so that to make some good, meaningful information out of it. Once you do all of that, you prepare your data, then you're now ready for data distribution and data visualization. You've got to be able to distribute that data to as many people as you want and empower your users, as I said, to create some ad hoc and custom visualizations as they would like to see the data. So let's talk about the supply chain management system here. That's a use case we're going to talk about. And as I said, supply chain system could be very, very complex. There are a lot of people and technologies involved in the supply chain management system. But for our discussions today, just let's focus on one data point, which is the GPS data. We all know GPS data is very, very important. But if you can develop some deeper insight into that data, it will quicken your incident detection and resolution capabilities by using some of the techniques which I just talked about, which are there in our product RTView. When it comes to supply chain management system, there are three important things you got to be considering. One is, your product sourcing. You may be sourcing your product from one vendor or multiple vendors in many cases. So that's one important part of your supply chain system. And then, of course, once you source the product, you have to send it to your customer. And then you want to track the journey of that product from end to end. So you want to have a very efficient journey tracking system so that you can, if there are any shipping delays, you can basically find out where the delays are, because certain products like medicines, wines, and fruits have to make it to the destination in time. And then, of course, as we know, in the supply chain management system, there could be a lot of people and technologies involved. There are people there are insurance companies, there are banks, there are logistics companies, there are freight forwarders and such. All these people play a very critical role in the supply chain system. And your product in the supply chain goes through a lot of change of ownership, and you've got to be able to find out who is the owner of your product and who has the custody of your product at this time. So let's look at two examples here. As I said, the process control and supply chain systems, and they have some similarities. So we're going to look at a data point first from a process control industrial application, and then we will look at a data point from the supply chain IoT data. What you're looking here is a tank, and this is a tank in a refinery, and the operator of that refinery in the control room is interested in the tank data. Is looking at things like whether the tank is filling or not, whether what's the service in the tank, whether there's gasoline or some other fuel in the tank, what's the temperature of that fuel, and when is the next sample due for laboratory. The same data, tank data, has a different context to a process engineer. The process engineer is interested in the same data, but he's looking at things like the minimum fill height, whether there are any associated equipments with the tank, and so on. And the product accountant of that refinery, of that product, is looking at the tank in a whole different context. He's looking at the volume and mass in the tank, essentially how much money is in the tank, how much is the giveaway, what's the product code, whether the duties have been paid, and such. So one data point, tank data, has different contexts for three different people in that organization. Same thing if we apply to the IoT space, the supply chain management system, and GPS data. Now here you're looking at GPS data and a screenshot from our product. And the IoT application engineer of a supply chain management system is looking at three things. Where is the product originated from? Where is it going, the delivery, and the total journey of the product. But the IoT business manager is looking at the same GPS data, but in a very different way. He is, as I said, there could be some logistics issues. You may be sourcing the product from one vendor. Now we have some problem there. You might be wanting to source it from a different vendor, and that vendor could be in a different country, different continent. And if you do that, you got to reroute that product to your manufacturing facility. And then there could be situations if the contract gets canceled or if there's a trade dispute somewhere, now you got to find a new buyer of that product. And that buyer could be again in a different region, different country. So you again have the reroute issues. And you want to make all these decisions in real time, whether it's a good idea to source a product from where your new customer is located, closer to that, or you want to ship the product all the way from different continents. So those kind of decisions IoT business manager has to take. And then the CFO of the same IoT company is looking at the same GPS data with a whole new different context. As the IoT business manager makes those decisions, whether to source the data from this vendor or that vendor and send it to this customer or take another customer on, but the CFO is continuously evaluating what's the cost of all these different changes which are happening in real time, and what's the best way to manage this situation. So GPS data to an engineer, to a business manager, to a CFO has three different meanings, three different contexts. So as I said, our product RTView lets you do that. It's a visualization platform for IoT and applications. It empowers the users to create their own custom displays and diagrams without any programming on an ad hoc basis. It's able to integrate data from many different sources, both IoT, non-IoT platforms, cloud platforms, on-premise systems, the public and private feeds, the example which you saw in the International Space Station case, and also, maybe directly from the IoT devices. And all this is coming in one place, as one dashboard. After you collect the data, you store the data, you normalize the data, make some good, meaningful information out of it, and then you have the ability to visualize. So these are some of the important things if you want to build or have a good industrial grade visualization system. So I think with that, that's what I had to say. Back to you, Tom. Thank you very much, everybody, for your time.
Okay, thanks, Praful. A lot of good information there about some of the ways that visualization gets used in an organization. I'm going to go through rather quickly here a few examples, and in particular focus on 4 ways that we like to think about visualizing and improving adoption. So the 4 ways we're going to talk about, basically these 4 here. Talk about a little bit about the architecture, why that's important. Then I'm going to talk about the importance of low-code rapid development. That's a key part of what we have found to be really valuable to improve adoption. You have to be quick. Another key thing that many people overlook is this notion about reusability of components. As you build things, you want to build up a library of things that you can reuse over and over again to accelerate your development. And then lastly, probably the most important one, is accelerating the rollout to target audiences. So you have to build visualizations, but you also need to make them available quickly and readily to different people who really can use the data. So on the architecture subject, just a quick note here. A lot of times people are excited about, they get real-time data, and they think about real-time streaming data. A while back, it was really popular. Real-time streaming data is going to be the key to good visualizations and lots of information. The problem with real-time streaming data is it may be fast, it comes in, but it doesn't always come in regularly, right? And so this is a problem that is often overlooked. And so one of the problems we see is that if you have a system that just talks directly to real-time streaming data, you open up your dashboard and you end up you have to wait until the next event comes in, and that's not good. And then finally, when the event comes in, then you see the current value. The problem with that is you don't want people to wait, so you always want to see the last current value. So there's an important architectural thing here that we have found critical, which is caching of real-time data. You have to have a system that allows you to cache the data, and also to provide historical context. In addition to caching, you need to be able to store history. If you go away from the page and come back, you don't want to wait while history accumulates. You want to see what happened in the past. Now, some of these things seem simple and obvious, but in reality, a lot of the tools and capabilities to do that are not easily integrated in your environment without a lot of coding and people involved in setting up a system. And so we've tried to help our customers address that with the tools that we provide. And also scalability. You often have geographically dispersed sources of data, and you want to be able to make it accessible to primary users who have access directly. You want to make it available to peripheral users out on the edge or out on the internet. And so you need to be able to distribute your data in various ways across the organization. Security is also another key factor involved here. And so you'll hear us in the rest of this talk, I'll be referencing this concept of a data server. So a key part of any visualization solution is having some centrally located access to data. And when I say centrally located, I mean it could be on the edge and it could be distributed, but it's a way to buffer the data. Another case that often comes up, even sometimes you have data in a database and you don't want 20 different users making the same database request. You want to cache it. So this concept of a data server in the middle is really key. Now we can go into more detail about that, but we don't have time in today's meeting. But that's an important aspect to enabling good visualization. And then, of course, the visualization components. We have something called RTDraw and RTView. These are tools that allow you to build up your visualizations. We'll talk about those in a bit. Now, in a full system, this is just a little system diagram. This is actually when Praful was showing the NASA space station. This is actually how that system is integrated, is implemented. We've got live data feeds coming down from the space station. They go through a streaming product. That they use a product called LightStreamer, and then they come in and we pick that feed off and we have a link that puts the data into a cache, maintains history in a database, makes that cache available to your browser, and then the user can use the RTView cloud tools to build up visualizations which they see. This is basically the architecture that we find is required for implementing any sort of visualization of real-time data. Now, moving on, low-code rapid development of custom dashboards. It's really critical here to be able to quickly build up displays ad hoc. For example, this is we have several customers of ours who are involved in smart devices, HVAC, or air conditioning units, or electrical metering. And often they want to just be able to build up some custom view that shows them what's going on. This is a particularly interesting one where we're measuring the temperature of a room that is being controlled by an air conditioner. You can see here the temperature going up and then going down when the air conditioner comes on. You can see the air conditioner turning on or off here. You see the moisture level. So this is a display that with low-code development, no code actually involved, just drag and drop off using the tools. Just drag these charts in, attach them to data, and in 3 minutes you have a page like this built up. That's low-code rapid development. All of these pages that we'll be showing you here are all done that way. Quickly drag and drop. This is we have palettes on the left. You drag the objects in. On the right side, you have properties that you can set. This is a drag and drop environment we call RTDraw. It allows you to build up your custom views. So it makes it possible to very quickly address user needs. And build up some fairly sophisticated displays. Here we're looking at some history on different metrics. And then notice on the left, you have a bunch of different display names. So as part of the system, not only are you creating individual displays, but you're organizing them together into a coherent application that allows the user to select through lots of information. The third area that we find extremely important is this notion of reusability of components, another often overlooked thing in building visualizations, right? So this here is a simple example of a sensor. That's actually 5 sensors grouped together into a device, and this little unit is assembled in a drag and drop fashion in the tool set. It consists of a bunch of images, a few text fields representing the 5 different measurements at this device, and there's the ID of the device. Now, this is one instance of this particular component that we have created on the fly in a few minutes. You made up a custom component that you want to use somewhere. Now, what you find is that often you want to use those in multiple places. Here's a simple example of a background, an image which is a floor plan. And there are 4 of these sensors that were positioned around the metal shop, the wood shop. This is actually from the Dallas makerspace. They had 4 of these devices, and each one is producing 5 measurements. And we just instance that reusable component 5 times, or 4 times. And then from here, I can drill by clicking on any one of those. And the ID of the device that is represented in each of those 4 instances is carried in the drill down to the next level where the particular device is selected if you want to drill and look at the actual history of it. So that's another really important part of doing this, is this development of reusable components. And we see that in many cases. Here's another space station display. Notice these 3, Node 3, US Lab, Node 2. Those are all essentially identical components, just fed with 4 different metrics. And so you can make that once and then instance it 3 times on the page. And then in fact, if you really look at it carefully, you'll see that the unit on top and the unit on the bottom are identical. So in effect, you can have what is a 2-level hierarchy of these aggregated together and all driven by a single data variable identifying the set of data associated with that particular unit. Very powerful, this reusability concept. I'm just quickly going over these things in the interest of time. Now, the 4th area is the rapid rollout. Okay? It's very important to be able to share data with as many users as possible to increase the value. Right? As I mentioned earlier, we sometimes have primary users, operational decision makers, and then peripheral users, sometimes management, suppliers. These are what we think of as peripheral users. And the displays that you present to those users can very often be different. So the ability to quickly put those together in an ad hoc fashion, address the requests that come in from these various users, and make those available to them quickly is key to adoption. And for that, and often in addition, you also want to be able to present multiple sources, not just a single source. You want to get multiple sources of data all aggregated together to serve those needs. So as part of a good visualization system, you need to be able to quickly publish and share and target specific audiences. So in the RTView tool set, we've created a whole mechanism for aggregating together multiple displays that you create, grouping them together in what we call a dashboard, and then making them available through a simple URL link that you can then expose to individual users, groups within the organization, or even to the public internet if you want to share it that broadly. This is another example of a sample dashboard. I just show you the product itself, and then we will move on to some questions. So here I am in the product. If I go to the design portion, you can see here we have a drag and drop capability. Drag objects in, and attach these to data. And I can select various types of data that I want to attach to and so on. I can create and publish dashboards, and here's a simple example of a collection of various displays. In this Dallas Makerspace one, for example, I've got the ability here to go to my top-level floor plan, and here's that example I showed earlier. I just click and I drill into that particular device, right? I have over here a totally different set of views, maybe for a different user. This is the turbine test rig, right? Showing data on a background here. I can select things like that. I can present information in that form. I can put all sorts of special kinds of meters and gauges into the picture. I can even go down with the tools that we provide, create displays that are full process mimic diagrams. So this is just an example of a dashboard that we created that has a collection of different kinds of data that might appeal to different users. Just in the interest of time, I want to wrap it up there. And questions, yeah, thank you for attending the webinar.